Morning everyone. I welcome you all to my brand new YouTube channel. Today I'm going to discuss about the ultrasonic testing, how it is done, calibration, about the machine and all of the information regarding what you need for ultrasonic testing. I will calibrate the machine and I will show you how to calibrate it, the various kinds of probes and related to that. First of all, let me introduce myself. My name is Vivek Malwal. I am a BTech graduate of Mechanical branch and I have joined Institute ANDT and I had gone for various tests in the magnetic particle testing, ultrasonic testing, radiographic testing, visual testing, liquid penetrant testing and RTFI courses. You can join this course if you are interested, and so let's start the topic. We have ultrasonic machine. The name of the machine is DigiScan DS324. Along with this machine we have various kind of probes. Basically there are three types of probes. First is the normal probe, which looks like this. There is a piezoelectric crystal inside this probe, which you can imagine that it's in between this casing. It looks like this. There is only a single socket, which you can see here. It's called mini LEMO. Then we have the other kind of probe called ER probe. There are two sockets here, two mini LEMO sockets, and the crystal, which I think you can see from here, that there is a partition between these two crystals. These one crystal in this casing, there is a partition and there is a separate connection for transmission and receiving. So these ports are the transmission, which is for transmitting of this, and then the second is for receiving. Okay. Moving on, the third type of probe called angled probe. You can see that this is called angled probe. The frequency, the angle and the size of the crystal is there, 8/9 of the probe. You can see the crystal which is inclined at an angle. You can see that, right? Okay. There's only one socket over here, which is the mini LEMO. So these are also three types, which are 70°, 60° and 45°. 70° probe is used for those materials for which the thickness is in between 0 to 30 mm in general. 60° probe is used for the materials whose thickness lies between 30 to 40 mm, and 45° probe is used for those materials which thickness is exceeding 40 mm. Okay, so this is the bifurcation of the which probe you will use in order to get your ultrasonic done. We have the 90-T as well. If you want to use if you want to use any kind of probe, you just subtract it from 90 -T, where T is the thickness, and then you will get the probe. Whichever value comes nearer to 90 -T, that probe you have to use. Okay, so that's about the probe. We have two kinds of blocks over here. You can see this one is IIW-V1 block. IIW stands for International Institute of Welding. It is V1 block, whereas the other smaller one is called V2 block. Same, IIW V2 block, International Institute of Welding V2 block. Okay, I'll tell you about this later. First, let's focus on the V1 block. This is a standard block which has been set up by the International Institute of Welding. It is everywhere the same. Okay, this is made up of mild steel and it is well polished to a state where you can easily find the dimensions using scale, and everything is standardized. Okay, so the distance here is of, from here to here it is 100 mm, from this point to this, from this bottom this point to this point is 300 mm, from this point to this point is 91 mm, and the circle which you see over here, you can see the circle, right? It's throughout the thickness. Throughout the thickness, this is a circle. You can see from here as well as from here. The thickness of this V1 block is 25 mm. Okay, and this transparent thing which you are seeing in front of you is nothing but perspex. Perspex is a kind of plastic. All right, and let me tell you various points where we are using, why we are using that. Okay, first of all, this is for calibration. From here to here, from the top to the bottom is for calibration. You can use the thickness as well for calibration. For this, it is for this you have to check for the sensitivity. Sensitivity is for this hole, 1.5 mm hole. This is for resolution. There it is 100. This is 85, the bottom of the notch, and the up is the 91. This is for resolution check. And let me just put it up over here. All right. This the distance which you are seeing from here top to this arc, this curvature is 5 mm, and this distance which you are having over here is 10 mm. You are calibrating the probe. If you want to check the dead zone, we are using this 5 mm and 10 mm, this, as you can see in the screen. You have to put your normal probe over here like this, then swivel it 15 degree up and down, one side to one side, and then come over to the 5 mm, this top one. Then if you see the dead zone up to a certain level, then the dead zone is there. If you don't see the dead zone, you will find that the dead zone is very far from that. Let's say it is, you have set the calibration to 25 mm range, then you will find if the dead zone is there, then it is okay, and if it is not there, then the dead zone is more than 25 mm. Same way, if you are finding from this side, let's say like this, if the dead zone is coming up to 25 in the CRT monitor, it is coming 25 and the lines are coming near to that, then it is up to 25, and if it is greater than 25, then you won't see the total of it. Okay, that was about the blocks. So this is also a small block called IIW-V1 block. The form remains the same, International Institute of Welding V2 block. So this is used for calibration of angled probe. Okay, and we have to put our probe like this, the crystal facing downward, and here we have to set this middle one. You can see that there is a 10 written over here, and you have to put it like this, and then you see that the radius coming, the beam path coming is here, from here to here, the beam path coming is 50 mm, and when you turn it to here, means like the wire is on the back, you have to see that this is coming to be 25. Okay, and then you complete the calibration. Okay, so there was the introduction about these two blocks, and so let me just give you a